This is our 2627. We're practicing graphing. You guys are going to have questions on your test that say, here is the function, identify the vertical asymptotes, and graph it. So all you have to do is graph the vertical asymptote. You're going to have a question that says, here is the function, what's the horizontal asymptote, and graph it. Then you're going to have one question that combines everything, where you have to graph and find the domain, the asymptotes, intercepts, and any additional points. I'll show you what I mean by that in a second. I gave you kind of a visual of what we're looking for. Domain is when we set the denominator not equal to 0, remember? That in turn helps you find the vertical asymptote. Vertical asymptote, horizontal asymptote is where the graph, when you graph it, does not exist. It's those horizontal and vertical lines. How do we find the horizontal asymptote? You compare the degree of the numerator to the degree of the denominator, all that stuff. We've gone over that a bunch. X and Y intercepts. In order for you to find the x-intercept, what do we do to find the x-intercept? What did our little cheat sheet tell us to do? Yep, we're going to say numerator equal to 0. To find the y-intercept, what do you plug in for x? Guys, to find the y-intercept of anything, what do you plug in for x? 0. Okay, that's easy. And then when I talk about additional points, you'll see what I mean by that in a second. All this is just pulling everything together. So before I even think about graphing, I'm going to find all this stuff for this first function. So let's talk about domain. How do you find the domain of a function, a rational function? Denominator not equal to 0. So we're going to say, okay, x squared plus 7x plus 10 cannot be 0. So, that's okay. Okay, so I'm going to factor this. What times what gives me 7 when I multiply, but 10 when I add? Okay, so x plus 2, x plus 5. So my domain, cannot be what? -2 or -5. Some of you want, okay, interval notation. Okay, so I have negative infinity to what? -2. Then from -2 to -5, then what? -5 to infinity, okay? So there's our domain. When we find the domain, we in fact also find what? Your vertical asymptote. So I have vertical asymptotes at what? At what? At what? X equals -2 and x equals -5. If you guys want to put those on the graph now, go ahead. I'm going to have a vertical line right here. And it's going to go through -5, correct? Yes? And I'm going to have a vertical line that's going to go through -2. Dashed, yeah.
Is that window open?
Mm-hmm. Oh, is the window open? I don't know. I doubt it. Okay, so the next thing we're going to look at, guys, is our horizontal asymptotes. So how do we find our horizontal asymptotes? What do? Compare the degrees. In this case, the degree of the numerator is 1. The degree of the denominator is 2. What's the inequality statement that I would write? 1 is less than 2. So when the numerator degree is less than the denominator, what is your horizontal asymptote? At y equals 0. Good. So on your graph, you have a dashed line at y equals 0. You guys with me? Okay. What's the next thing it's going to ask for? Intercepts. X and y intercepts. Okay, so I'll do that over here. How do you find the x-intercept? Set the numerator equal to 0. Good. So I'm going to look at my numerator and I say x equals 0. What do you know there, guys? It's 0. That's where we're going to go right here. Good. If I asked you for the y-intercept, how do you find the y-intercept? Plug in 0 for x. So I have g of x equals, look, I have 0 over 0 squared plus 7 times 0 plus 10. So if I simplify that, guys, I have 0 over 10, which is what? No, not undefined. 0. So my y-intercept is at 0. Okay, is that crazy hard? No. So once you find all of this stuff, okay, we're good. you have to figure out where your graph exists. That's what I mean by additional points. Do you see your horizontal and vertical asymptotes? Does everybody see that? Do you see that there are 6 different areas of the graph? There's an area up here, then there's one down here, right? Then there's one in between here, then there's one in between here, then there's one over here, then there's one down here. Does everybody see those different areas I'm talking about? Because when you graph, your graph gets really, really, really close to those asymptotes, but doesn't do what? Doesn't touch. So you have to figure out where those things exist. What you do is you just pick a point in each little area. And I'll show you what I mean in a second here. But let's pick a point in the yellow. Pick a point in the yellow area. -6, 3. Okay, so we're picking this point right here. -6, 3. Agreed? Okay. You don't have to say -6, 3. Just pick a number that is above or below. Not even that. Let's pick a number. Look, here's my horizontal asymptote, right? At 0. And my vertical asymptote at -5. Pick a number on the x-axis that's bigger than -5. Or smaller, we'll say. To the left of -5. Put it that way. Okay, -6. So if I plug in, if I take my function, and I'm going to say, okay, here's my function, g of x. I'm going to plug in -6 for all of my x's. So I have -6 over -6 squared plus 7 times -6 plus 10. All right, you guys see what I did? I'm just plugging in x. I'm trying to see what I get for y. So when I do this, I have -6 over 36 minus 42 plus 10. Agreed? So -6 over, what's 36 minus 42?
Yeah, it's -6.
Okay, -6 plus 10 is what? So then this reduces to -3 over 2. Agreed? So when I plug in -6, I get, what did we say? -3 over 2. So tell me, guys, where is the point -6, -3 over 2? Is it, what color section is it in? It's in the blue section, correct? It's below the horizontal asymptote. So then you know that your boomerang exists here, not in the orange or the yellow. So let's go to, do you see the middle section? I'm looking at the area between -5 and -2 on the x-axis, yes? Yes or no? Yes. Okay, so pick a point on the x-axis that's between -5 and -2. -4, okay? You don't have to use all the same points, doesn't matter. So if I plug in -4, so I'm going to try g of -4 and see where my point ends up. So I have -4 over -4 squared plus 7 times -4 plus 10. What's -4 squared? 16. Minus 28 plus 10? Okay, so I have -4 over, I have -12 plus 10, -2. So that ends up being what number? Positive 2. So when I plug in -4, I get positive 2. In this middle section, guys, where is the point -4, positive 2? Is it in green or is it in purple? So that means it's going to be up here. It's going to get really close. Do you understand what I'm doing? You're just plugging in to figure out, is it above or is it below? And then I go to the right and I say, okay, I need a number that's bigger than -2. What's an easy number to put in that's bigger than -2? Okay, -1. So I'm going to say g of -1. Well, my function is -1 over, where is it? Oh, -1 squared Read it to me, guys. Negative 1 squared plus 7 times negative 1 plus 10. Okay. So I have negative 1 over. What's negative 1 squared? Minus 7 plus 10. So negative 1 over what? 1 minus 7 is negative 6. Plus 10 is. So when I plug in negative 1, I got what? Negative 1/4. So where is the point positive 1, negative 1/4? Is it in the pink or is it in the gray? It's down here in the gray, right? So then your boomerang is down here. All you need to do is understand you have sections. And when you have, you'll generally have 3 sections if it's squared because you have 2 vertical asymptotes. You figure out, is it in the top one or the bottom one? Is it the top one or the bottom one? Is it the top or the bottom? Does that make sense? A little bit? All right, let's do another one. Just get them close. Get them close to your asymptotes.
That's not a test.
Mm-hmm. You know how to do everything. The only thing that's new is just the graphing part. But the last question will be, find the domain. Ba 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 ba. Yeah.
So that question is gonna have like this domain, like this for that. Like that's the only question.
It'll have one question and it'll say what is the domain, what's the vertical asymptote, what's the horizontal asymptote, what's the and then it'll say to graph it.
Okay, but then like how many in total for the test? The question.
I think there's 12. This being the 12th, so probably around 15 or 16.
Okay.
Yes, sir. Okay, we're going to do the same thing for this second one. We're going to find all this information out. So the first thing I'm going to do is I'm going to look and I'm going to say, all right, what am I working with? What is my domain? How do I find domain? Set the denominator not equal to 0. So x squared minus 16 cannot be 0. X minus 4 and x plus 4. Good. Cannot be 0. So x cannot be what 2 numbers? Positive or negative 4. So in turn, when you guys find that, what do you find your vertical asymptotes to be? At x equals negative 4 and at x equals 4. Does everyone understand what I just did there? Uh-huh. Let's put our asymptotes. Where are we going to put our vertical asymptotes? At negative 4 and positive 4. So I'm going to try and make this as clear as possible.
We also draw the dotted lines for the graph tomorrow, right?
Say it again?
Like the lines.
Yeah, they need to be dashed. They need to be dashed like that.
We get points off if we don't like the
Yes, because they're not lines. They're
get all the points off.
just don't do it.
Okay.
I don't know right now how many points I'm going to take off, but just don't do it. It needs to be a dotted line. I'll probably take all of them off because if you draw a straight line, then that's not an asymptote. All right, horizontal asymptote. How do we find our horizontal asymptote? Compare the degrees. So the degree of the numerator and the denominator happens to be the same. So what do we know? Nope, doesn't always equal 1. It's the leading coefficient of the numerator, which is 2, over the leading coefficient of the denominator. So I have a horizontal asymptote at y equals 2. So I'm going to go down to my graph. I'm going to go right here. Now, before I start, I'm going to find intercepts here in a second. But do you guys see the 6 portions of this graph? So the first section that I'm going to look at to find where to put my boomerang, ladies and gentlemen, is right here on the x-axis. You guys see what I'm talking about? Okay. So then the second section is in between what 2 numbers? Negative 4 and positive 4. Good. And then the last section is between what 2 numbers? Or is where? 4 to infinity. All right. You see those 3 sections I'm talking about? We'll come back and graph in a second. But what are some other things I need to find? I need to find my intercepts. So how do I find x-intercepts? Set the numerator equal, to 0. So what do? Divide both sides by 2. x squared equals 0. So x equals 0, all right? And then, my friends, how do you find y-intercepts? Put the x in here equal to 0. So if I have a y-intercept, I'm going to say it's 2 times 0 squared over 0 squared minus 16. Okay, well, what's 2 times 0 squared? 0. And what's 0 squared minus 16? Negative 16. So where's my y-intercept? Okay. Questions? Yes, no, maybe? Yes, sir.
For the horizontal,
Asymptote?
yeah. So if it, like, you compare it, so then it's 2 equals 2 is the top one and the bottom one.
Yep.
So then how did you get like 2?
If the numerator degree and the denominator degree are the same, you take the leading coefficient of the numerator and divide it excuse me, by the leading coefficient of the denominator. So, since my leading coefficient here is 2, and then down here this is 1, 2 divided by 1 just gives me y equals 2. All right, so now we need to find out where we're going to put our boomerangs. Yes, sir. All right, now I need to find points. So the first section I'm going to look at is to the left of the vertical asymptote. So pick an x value that is to the left of the first vertical asymptote. Anybody? -5. Okay, so let's plug in -5. When I plug in -5, let's see what happens. What's my function? 2x squared. So 2 times -5 squared over what? 5 squared, -5 squared minus 16, okay? So I have 5 squared is what? -5 squared is what? So 25 times 2 is 50 over 25 minus 16, yeah? So 50 over 9. What is that about? 9 goes into 50 how many times? Not like, how many times? 5, and then with how much left over? Okay, 5/9. So when I plug in -5, I get 5 and 5/9. Where is that point? -5, 5, and 5/9. Is it above your horizontal asymptote or below? It's above. So where am I going to draw my boomerang? Above, up here. Does that make sense?
You just draw it anyway?
Just get as close to the asymptotes as you can.
Okay.
Now I'm going to go here, and I have to pick something in between -4 and +4. What would be the easiest number to plug in?
0, 0.
0? Okay, hang on a sec. Plug in 0, because 0 is easy to work with, correct? We like zeros. So if I plug in 0, I'm going to plug in 0 and see where that lands me. I have I have 2 times 0 squared over 0 squared minus 16. Well, what's 2 times 0 squared? 0 over 0 squared minus 16 is -16. What does that equal?
0.
So where is the point 0, 0? It's right here, right? So where's my parabola going to be? My boomerang? Is it going to be below the horizontal asymptote or above it? So there you go. Just draw it. Whoop. And then the last thing I need to find is that last section to the right of the horizontal asymptote. So, the vertical asymptote. Pick a number to the right of the asymptote. 5, okay? So if I plug in 5, let's see what happens. I have 2 times 5 squared over 5 squared minus 16. Where am I getting this formula, or not formula, this equation to plug numbers into? From the original, okay. So I have, what is 5 squared? Times 2. 50 over what? Okay, so what is that? We already know. 5 and 5/9, right? So where is the point? +5, 5 and 5/9. Is it above that horizontal asymptote or below? It's above it. It's somewhere up here, so we're just going to go just like that. And there's your function graphed. Does that make sense? I want to look at this, guys, real quick. Just so you don't get thrown off by this. Look, everybody look. Look, 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 look. What am I talking about here? What are we looking at? Multiplying and subtracting.
Oh, sorry.
That's okay. Don't get overwhelmed by something like this. Simplify this side. Then simplify this side. Then worry about subtracting them. So the first thing we're going to do is FOIL. What's 5 times negative 3? What's 5 times negative 2i? Good. 7i times negative 3. Why did I write that? You're right. 21i. And then negative 7i. Excuse me. Positive 7i. Negative 2i. As soon as I see I squared, what do? Cross it off and change the sign in front. So your reals are on the outside. What's negative 15 and a positive 14? And then what do I have here? Negative 31i. Agreed? Minus. Do the same thing over here. What is negative 4 times 5? Negative 20. What's 4 times I? Negative 4i, you're right. What's 6i times 5? And then what's 6i times I squared? Just kidding. 6i times I is 6i squared. Ay. So I see I squared. What do? Cross it off. Change the sign. So here's my reals. What's negative 20 and a negative 6? Negative 26. And then what's negative 4i and 30i? Why? What am I doing? I'm sorry. I'm thinking ahead at what I'm looking at. Okay, so negative 26, right? And then we said plus 26i. So that goes right here. Negative 26 plus 26i. Does everybody see what I did?
Yeah.
All right. And then now what do? Distribute the negative. Good. So you have negative 1 minus 31i plus 26, right? Minus 26i. So my reals are here. What's negative 1 and 26? Positive 25. And then what's a negative 31 and a negative 26? Minus 57i. Don't get thrown off if you see something like that. Don't get thrown off if you see something like that.
Pardon the interruption. Alejandro.
Zeros. First thing I look for, if there's 4 terms, I look to see if I can do what? Group it. Is this going to group? No. So now I have to look at what?
The greatest common. Oh no, sorry.
You could do synthetic division.
I'm going to use synthetic division. What are the factors of 20? Plus, minus 1, 2. Why am I putting 3? 4, 5, 10, and 20. All right. What do you guys want to start with? What do you want to try? 1. Okay. So I have 1, negative 4, negative 2, and 20. 1 times 1 is? Negative 4 and 1 is? Negative 3. Negative 3 and 1 is? Negative 2, negative 3 is? Negative 5 and 1 is? Is this going to work? Okay, what do you want to try? We'll try negative 1? Okay. One times negative 1 is? Negative 4, negative 1 is? Negative 5 and negative 1 is? Negative 2 and 5 is this going to work? Okay, what do you want to try? Okay. One times 2 is? Negative 4 and 2 is? Negative 2 and 2 is? Negative what? Negative 2 and negative 4 is? Negative 6 and, nope. All right, so what now what? Negative 2? Hold on, let's try negative 2.
Ms. Meadows, how did you know it wasn't gonna group like from the beginning?
Just looking at it. Because if I group this, I can take out x squared, and then I'll be left with x minus 4. I know if I took out 2, I wouldn't be left with x minus 4.
Oh.
So negative 2, 20. What's 1 times negative 2? Negative 2 and negative 2. Negative 4, negative 2. Negative 6 and negative 2. What's negative 2 and 12? 10. 10 times negative 2 is negative 20. So what do we know? Okay, so x equals negative 2 is a solution. Okay, everybody look, boys, pay attention. What am I left with here? X squared minus 6x plus 10 equals. All right, all of the ones that we've done so far have factored at this point, yes? Does this factor? So if you get to a quadratic and it doesn't factor nicely, what do? Quadratic formula. You'll have a question on your test that says use the quadratic formula, but when you're finding all the zeros, you might have to use the quadratic formula again. It's not lame. But you are going to have to probably factor. So does anyone need a refresher on the quadratic formula?
Yeah, please.
Okay, might as well. What's my A term? 1. What's my B term? Negative 6. And what's my C term? So my quadratic formula, for those of us that don't remember, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You will have a question on your test that says solve using the quadratic. So you need to know the quadratic formula. You might come to a zeros problem where you have to use the quadratic formula. So I have negative 6 plus or minus, what is b? So negative 6 squared minus 4 times a, which is 1, times c, which is 10, all over 2a, so 2 times 1. Correct? All right, so if we simplify this a little more, we have 6 plus or minus, what's negative 6 squared? Minus 40 over 2. 6 plus or minus negative 4 over 2. What's the problem? It does not that it doesn't factor, it's an I. Good. What is the square root of negative 4i? Oh my gosh, I keep telling the answers. What is the square root of negative 4? 2i. So you're left here with 6 plus or minus 2i over 2. Last thing.
Wait.
Last thing I do here, folks, is what? Simplify. How can I simplify this? 2 goes into 6 3 times, and 2 goes into 2 1 time. So I'm left with 3 plus or minus
And yeah, those would be the 2 zeros.
All right, how do we feel? We all right? I want to go over 2 more things.
So you put like x equals that, or you just put the answer there?
That's fine like that, because you have an equal sign. I know you start off with x equals. Now, if you have something like this, before you guys, we didn't do anything like this. Yes, we did.
We didn't do anything.
Exactly. This is the same. I can write this as 1 what? Plus 12i. I can write this as negative 5 what? Minus 3i. Now this just becomes a problem of adding. Okay, so let's not freak out. The entire test, exactly like that. Okay, wait, let me do one more. I thought of something. X to the 4th.
It looks hard.
I know it does.
Wait, why are you doing something?
Because that's my job. Find all the zeros.
You have to put in a thingy.
Oh yeah.
No, not.
No, we're not.
You can straight up factor it.
How wait. Why can we straight up factor it?
Because they're all squares.
Okay, do you guys see that this is a perfect square trinomial? This isn't the difference of perfect squares. But this is a perfect square trinomial. What goes in the front of each parenthesis? X squared. Good, guys. What goes in the back of each parenthesis? 5. What goes in the middle of each parenthesis? Plus. So if you are asked to find all of the zeros, how many zeros should you have with what you started off with? 4. So when I go to solve this, ladies and gents, x squared plus 5 equals 0. X squared plus 5 equals 0. Do we have multiplicity?
Yes.
obviously, because it's the same thing. But when I solve this, I'm going to subtract 5 from both sides. So I get x squared equals negative 5 in both cases. Yes? All right, now what? If I take the square root, what goes in front of my answer? What goes in front of my answer? Plus or minus. What else is going to go right there? Why? Because there's a negative underneath the square root. Do we know the square root of 5?
No.
So I just have it like this.
Not like before.
Correct, right? You have 2 answers here, 2 answers there. I just wanted to bring that to your attention. We haven't talked about perfect square trinomials in a minute, so I just wanted to bring that to your attention. I'm not saying it's going to be on there. I'm not saying it's not. I just want you to not be surprised with stuff. Yes, sir. In conclusion, to review for your test tomorrow, there are videos on YouTube for you to watch under my channel. The 2425 quiz review, the 2627 practice problems I worked out yesterday, and then the graphing practice. So brush up on that. When you come in tomorrow, we need to get started right away because I want to make sure that you guys have plenty of time.